I would like to introduce you a very nice problem. It's coming from the China. So here is the following application. We have f from R to R satisfied these following three conditions. We get f of 1 equals 1 for all x as a real number. The second condition, we get f of x plus number 5, which is inferior or equal to f of x plus 5. The third and last condition, we have f of x plus number 1 is inferior or equal to f of x plus number 1. So we are going to have this expression g of x equals f of x plus number 1 minus x. So the goal, we are going to evaluate g of 2002. Okay, if you take a look at the first and second condition, they are almost similar. Okay, so the only difference, we get f of x separately with number 5. Here is x plus 5 inside of f, but this one, starting with the left hand side of the inequality, we get x plus number 1 inside of the f, which is inferior to f of x plus number 1 separately. Now let's get started to see how to interpret this one. Okay, so what to do here, I'm going to combine these two conditions together. So starting with the first condition, so I get f of x plus 5 is inferior to f of x plus number 5. So I'm writing this one as it is. So now I'm going to apply the second condition on this one. So if I'm going to apply the second condition on, especially on this one, so I get this one is inferior to f of x plus 4 plus number 1. So keep doing this one all the way down. So this one also will have f of x plus 3 plus number 2 here. Okay, so keep going with this one. So I get this one is inferior to f of x plus 2 plus number 3. This one keep going down, but this one is going up. Okay, so the which is inferior to f of x plus number 1 plus 4. Lastly, I get f of x plus number 5. So what we have here, I have f of x plus 5, which is between f of x plus number 5. By applying the quiz theorem here, we get f of x plus 5 between the same value, f of x plus number 5 and f of x plus number 5. This one immediately is telling us f of x plus 5, which equals f of x plus 5, like this. What to do here, moving over to the second condition, so we get f of x plus number 1, which is inferior to f of x plus number 1. So what I did here, I just wrote the second condition over here. So applying this condition on this one, exactly this one is going to be written on the form of f of x plus number 1, like this. Also applying this condition on this one as I have here, this one exactly is a f of x plus number 1. Okay, also applying this condition on this one exactly equals f of x plus number 1. What do we get here? So this one, we get f of x plus number 1 is inferior to f of x plus number 1, which is inferior to f of x plus number 1. Okay, so using the squeeze theorem again here, we get this one between the same number, this one and this one. This one immediately is telling us f of x plus number 1 equals f of x plus number 1. I have extracted a nice formula here. Now let's bring this one at the top and continue solving this one. So from the last board, we get this nice fact. So we get this nice relationship between f of x and f of x plus number 1, differ by number 1. So what to do here, we are simply going to calculate some values of f. So I get here f of 2, which equals, by using this one, which equals f of 1 plus number 1. We already know f of 1 equals 1, which equals 2. Doing the same thing on this one, doing the same thing for the next value. So I get f of 3, which equals f of 2 plus number 1, which equals 3. And then f of 4 equals f of 3 plus number 1, which equals 4. This one follows similarly all the way down to the f of 2002. So we get f of 2002, which equals f of 2001 plus number 1. Since the pre-image of the same number is going to give us the same number, which one immediately is going to give us f of 2001, which equals 2001 plus 1, which is equals 2002. Now let's go back to this function. Plug in x with 2002, so I get g of 2002, which equals f of 2002 plus number 1 minus 2002. F of 2002, it gives us 2002 here, plus number 1 minus 2002. This 2002 cancelled out. I will be left with 2002, which equals number 1. So I have found this value, which equals 1. So I have done this problem. Thank you for watching. I will see you next video. Bye.